All right, let's pull back the curtain on one of the most critical yet kind of misunderstood fields in our modern world, software engineering. So, what do these two things have in common? I mean, one lives on your phone, and the other is literally responsible for thousands of lives up in the sky. The answer? They are both ridiculously complex pieces of software, and they're just a tiny peek into the code that invisibly powers pretty much everything we do. And it's no exaggeration to say our world runs on code. The scale of our dependency on software is just staggering. It's not just a part of our economy anymore, it's the foundation of it. And notice that word, all. This isn't just about Silicon Valley. We're talking about everything from farming to finance, from manufacturing to medicine. Software isn't just a handy tool, it's the core infrastructure that our entire global economy is built on. But, being this dependent on something creates a massive challenge. For all this to work, the software has to be reliable. And building good, reliable software is incredibly difficult, super complex, and, as we're about to see, very expensive. So let's just look at the upfront cost of getting a piece of software made. About 60% of that price tag is what you'd probably expect, the cost of actually designing and writing the code. But look at that other chunk. A full 40% of the initial budget is spent just on testing, just on making sure the thing actually works and doesn't fall apart. But here's the real kicker. That huge upfront cost, that's just the tip of the iceberg. The cost to maintain, update, and fix a piece of software over its entire life can be several times what it costs to build in the first place. It's kind of like buying a car, but then paying for 3 more cars just in repairs and upgrades over the years. Wild, right? And that's the million-dollar question, isn't it? When the stakes are this high, you can't just cross your fingers and hope for the best. We need a real, structured, disciplined way to get a handle on all this complexity. And that brings us to the hero of our story, software engineering. This is the discipline that was created to bring order, to bring predictability and professionalism to the often chaotic world of making software. Now, the key phrase here is engineering discipline. Think about it like this. You wouldn't want someone building a bridge by just starting to weld beams together, right? Of course not. You'd want blueprints, you'd want material science, you'd want a rigorous process. Well, software engineering is all about applying that same professional, structured mindset to building code. Okay, you might be thinking, wait a minute, isn't that just computer science? And that is a totally fair question. It's a point of confusion for a lot of people. They're definitely related, but their focus is completely different. Let me show you. So the real difference is focus. Computer science is all about theory. It explores the fundamentals of computation, what's even possible. But software engineering, that's about the practical, real-world challenges of actually building and delivering useful, reliable software on time and on a budget. And then you have system engineering, which is even broader, looking at the whole shebang, hardware, software, and even the people involved. Okay, so if software engineering is the discipline, what's the actual blueprint? Well, it really comes down to a clear set of activities and focusing on some absolutely essential qualities. Pretty much every professional software project goes through these 4 key phases. First, you have specification, which is just a fancy way of saying, what the heck are we building? Second is development. That's the actual design and coding. Third is validation. Does it actually do what we said it would do? This is where that massive 40% testing cost comes in. And finally, evolution, keeping the software running and updating it for the future. And this right here is what they're aiming for. See, good software isn't just about having cool features. It has to be maintainable, so it can change as needs change. It has to be dependable and secure, so it doesn't crash on you or get hacked. It should be efficient, so it's not draining your phone's battery or slowing your computer to a crawl. And of course, it has to be acceptable. It has to be understandable and actually usable for the people it was built for. But here's the thing. Building great software takes way more than just being a technical wizard. Because software has such a massive impact on people's lives and on society itself, being a software engineer comes with some really serious professional responsibilities. This quote really just hits the nail on the head. When the code you write is handling someone's money or their medical records or is controlling a car, your responsibility goes way, way beyond just making the program work. So, a professional engineer has some clear ethical lines. They absolutely must maintain confidentiality and protect user data. They have to be honest about their own competence. You don't take on a job you know you can't handle. They must respect intellectual property laws, and of course, they can't misuse their skills for malicious reasons. It's a huge deal. And that really brings us full circle. We started in this world built on incredibly complex, expensive, and maybe even fragile code. And what we've seen is that software engineering is our best strategy for managing that chaos, for applying real principles and professional ethics to build systems we can all actually trust. So it leaves us with this final thought. Who is responsible for all this code? Is it the individual programmer, the company they work for, us, the users? As software gets more and more woven into the fabric of our lives, figuring out the answer to that question is one of the biggest challenges we're going to face.